Hi everybody, today's presentation is entitled Can't See the Wood for the Trees, Just Focus on the Logs. And of course, all puns are intended. Quick introduction, we're doing a joint presentation today with myself. My name's David Tatsall, I'm the CEO of Integral. We're the makers of FusionReactor Application Performance Monitor. And we've been working with Cold Fusion and supporting the community since 1998. Also joining us to show off some of the technical aspects of what you can do with the logging platform and talking about the architecture that I'm going to present shortly is Mikey Fluid. Mikey is our head of technical support for FusionReactor. So this presentation is going to discuss companies are using logs, who benefits from what, and we're also going to show you what components can be used to build a modern, scalable, open source log processing architecture using Grafana Loki from Grafana Labs. Finally, we're going to demonstrate how FusionReactor's new log capture and analytics capability can transform your ability to manage, process, and gain tons of value out of your good old logs. So without further ado, I'm going to start. Okay, so let's talk about logs. I'm sure that for the developers amongst the audience, you've all written logs into your applications at some point. And you may think that analyzing logs is really something which only software developers are interested in. But nothing could be further from the truth. In reality, log analysis is more important now than ever before, and it affects every aspect of your business, including development, finance, legal, human resources, sales and marketing, compliance, security, and operations. Logs are essentially for everyone, developers, DevOps, and the business. So let's take a look now at what each of these different groups are looking for with logs and how we can make them more effective. So what do developers want? Developers are writing logs to capture all manner of detailed information, including events, variables, trace markers, information-related information, errors, and warnings. The two main reasons why developers utilize logs is to understand what's happening in the code and using logs to actually debug their applications and perform root cause analysis. Recently, D-Zone did a publication where they stated that 94% of all developers are using logs as their primary method of debugging and to perform root cause analysis in production environments, which is pretty amazing, really. How can we make developers even more effective? Having more effective tooling will make a lot of difference in the effectivity of developers in using logs. As I hope we can demonstrate later in the presentation, the introduction of automatic labeling and indexing opens up a completely new perspective on logging and what you can achieve using logs. So what do operations want? DevOps teams want to understand their applications better, and they want to use logs to allow them to detect and address application issues before they get into production. In general, I'd say they've got a much broader set of requirements for logging, with things like containers, capturing code hooks, network activity, traditional infrastructure logging. All these are generating events, and this data can provide any number of valuable insights for operations. DevOps are, of course, also deep inside the CI/CD toolchain, logging their software development processes so that they can ensure maximum optimization. For example, the deploys occur at the times considered the least intrusive to an organization's workforce. So how can we make DevOps more effective? Well, both log management and DevOps have been in use for a long enough time that they need to look beyond the core capabilities and expand to how they can be used together in more unique and differentiated ways. For example, leveraging machine learning capabilities like time series anomaly detection, TSADs, DevOps teams can use historical log data such as web application traffic to explore user engagements and detect anomalies among the noise. And finally, what does the business want? I'm pretty sure that the business wants to earn more money. And there are many, many ways in which the business uses log information to reach financial as well as other goals. The business wants better products and are using logs to analyze how their customers are using their products so that they can improve them. From the sales and marketing perspective, logs are analyzed to quantify the effectiveness of sales campaigns. Information such as referring sites, actual pages accessed, conversion rates, all can be used to tweak different aspects of the sales effort. Resource planning is also another major focus for log analysis within the business. So one of the worst things any company can do is miscalculate which resources are necessary to support its business operations. From network bandwidth to storage capacity to CPU cycles, businesses have to get these quantities just right. Not enough resource in any area can lead to poor performance, frustrated customers, and eventually can lead to lost sales. Finally, the business is using logs to satisfy compliance mandates. Every organization has internal policies, security policies, employee policies, legal policies, etc., etc. In fact, most organizations have regulations such as HIPAA, Sarbanes-Oxley that they must adhere to. The only feasible way to ensure policies are followed and regulations are met is through log analysis. How can we make the business more effective? We've seen a trend in the past years as data scientists have become the new heroes inside organizations as they turn raw data into valuable insights, enabling companies to grow and compete. This trend will continue and will also be augmented by machine learning and artificial intelligence in the future. Adding these capabilities means that it's possible to grow revenues by 2-digit percentages. Let's go back to basics. What is a log? In its simplest form, a log consists of some data, usually a timestamp, to let you know when the log was recorded, and the source of where the log came from. From a developer's perspective, if you're tracking events in your applications, you're also quite likely to use a type definition, which indicates the type or severity of the message or the log which is being written. So the format and content of an application log are generally determined by the developers. Where do logs come from? Logs are coming from all over the place, from web servers, applications, services, databases, and of course from your network infrastructure. FusionReactor also captures all of your metrics and telemetry whilst it's monitoring. So all of this information is placed into separate log files and is made available in the log archive viewer inside FusionReactor. And we'll also be seeing shortly how this information is also made available within FusionReactor Cloud and how we're augmenting FusionReactor Cloud with the log processing capabilities, which we're going to talk about very soon. So how much data are we talking about? I think it's fair to say that logs are directly and linearly linked to your application size and load. It's very easy to very quickly use a lot of disk space to store logs. Some issues that we've got to deal with. So the information logged isn't consistent. Since most of these components are written by different developers working according to different logging styles or even no styles at all, the actual values that can be derived from the logs varies considerably. So log files are split on a single host. In this case, logs are often not easily available from a single file, but rather they're spread out across multiple files in different places in the file system. Logs are split and chunked into small files, which tend to be overwritten across time. This can also cause frustration when trying to locate a specific log line that was captured a while back. So logs are spread across multiple hosts. Our applications are not single beings. They're spread out across multiple instances. They're orchestrated in Kubernetes clusters. They're packaged into containers. Figuring out where in your application's topology a specific piece of information is coming from can also be very tricky and very difficult. Logs are also expensive to store. Even though disk space is relatively cheap nowadays, persisting logs over time on disk, especially as you deploy more and more software and that gets easier, it means that a ton of space is consumed for the sole purpose of storing log files. This can quickly rack up lots and lots of costs. Logs are also expensive to analyze, so parsing enormous amounts of information is a time and resource-consuming task. What are the tough parts? Let's take a look now at how we can build our logging system. So even while writing logs is relatively simple, consuming them and visualizing them in order to gain value is the real challenge here. Is it so difficult to build a logging system? Maybe you're thinking, that can't be that difficult. You could just go ahead, build your own logging system. It's just capturing some data onto your SSD drive, right? No, wrong. Nor is it going to work if you add your super SSD RAID array. This isn't a good idea. It's called vertical scaling, and you don't want to do that. It's never going to fly. Whatever we end up building must be able to grow. As you can see from this graph, you can very quickly get a lot of log data being sent to your applications. And one thing is very clear, your solution must be scalable. We need a solution which is designed for that right from the outset. Your log system must support tons of data. We're going to be sending it a lot, and I mean a lot of log information into your logging systems. So we need to come up with an architecture which is going to allow us to support that moving forward. What components do we need for this? Firstly, we're going to need a log processor. Wherever we're generating logs, we also need to think about how we're going to get our logs. Do we pull for them or do we push them? Secondly, we need some storage so that we can store the logs, obviously. Is this going to be a file store? Is this going to be a blob or an object store? Maybe it's going to be a database. We've got to figure that out, but we definitely need some storage in this mix. And finally, we need a user interface. And this is not where the developers amongst us start thinking, come on, I know grep, I know awk. Surely these tools are powerful enough to get the data out of the log files. Well, the answer is definitely no, no, no. We need something different to that in order to get the real benefits. So the ideal solution is that you can come up with a single interface so that everyone can use that user interface in order to get value out of your logs. So for our open source log processing referencing example, we're going to use a solution from Grafana Labs, which is called Grafana Loki. Grafana Loki is a scalable multi-tenant set of components that can be composed into a fully featured logging stack. Loki is built around the idea of only indexing metadata about your logs. This metadata is what gets captured as labels, and we're going to go into more detail and come to that in a moment. So let's take a look at which components our Grafana Loki solution needs in a little more detail. In this example that you can see on the image here, we're using ColdFusion 21, and we're storing our logs to disk, what you can see in the process logs component there. We then need a logging agent, and the agent is going to be used to ship the logs off to the log ingester and wherever we designate as our end storage for our logs. For a logging agent, there are many open source options available. For example, Logbag, which is one of the most widely used logging frameworks in the Java community and is a replacement for the popular Log4j. You may also have heard of FluentBit, an open source log processor and forwarder, as well as FluentD. In our example here, we recommend using Promptail, which is a logging agent which ships the contents of local logs to a private Grafana Loki instance or Grafana Cloud. Note that Promtail is polling for data. We're not pushing the data from the client application. The logging agent will then send the logs via HTTP to the ingest endpoint. On the ingest side of things, we also have many options in the form of commercial products such as Papertrail, Logstash, or enterprise services such as Splunk. Some of these also offer free options such as Papertrail, which is a free plan to allow you to store up to 50 megabytes per month and will let you search within the last 48 hours worth of logs. Although please note, 50 megabytes is really not a lot of space when you start processing logs. So the second phase is that we need to store and visualize this data. In theory, you can choose wherever you wish to store your log data. The data itself is generally compressed and stored in chunks in object stores, such as S3 or Google Compute, or you can even store it locally on your file system. You may want to look at using Amazon S3 storage. And if you're a new customer on Amazon, you can benefit from a 12-month free plan. And they have some offers for an always free tier in some cases, but of course it's Amazon. They're going to get your money eventually. In order to access your log data, we need a query language. One such language is LogQL, which is Grafana Loki's PromQL inspired query language. There are two types of LogQL queries, which are log queries and metric queries. Log queries return the contents of log lines and generally using labels for searching and organizing the results of queries. Metric queries extend log queries by applying a function to log query results. This powerful feature enables us to create metrics from logs. And queries act as if they were a distributed grep to aggregate and combine data across all of your log sources. We mentioned earlier, labels are a pretty important aspect here. And logs are not really easy to read and spot the context of what you're interested in. So labels provide structure and organization into this mix. Labels are automatically captured and indexed directly from your logs. Field data is also automatically indexed and allows us to instantly graph data and analyze statistics of how your logs are being used. Using labels gives us so much more flexibility to analyze logs and turns the mass of log data into an organized, indexed, and insightful collection of useful information. And at this point, I'm going to hand over to Mikey, who will go into some more detail about the architecture and how we're using logs within FusionReactor, along with some real-world examples of how you can use logs to solve real-world problems.
The first thing to quickly cover is how logging agents typically function. You'll see in the top diagram we have an application that generates logs and stores them to disk. We then have a logging agent polling or scraping those logs and sending them to a HTTP log ingest endpoint. This ingest endpoint could use HTTP, but it could also use gRPC depending on their implementation. Now, FusionReactor has a very similar implementation to this. However, the agent does a lot more than just scrape logs. So based on the monitoring it does, it will generate its own log files for application performance metrics and ship those alongside your logs. And it will ingest data in exactly the same way that a typical agent would. I have a single CFML application running. It's deployed on Adobe CF 2021 and is deployed via command box in Docker. The agent has 3 nodes running behind the load balancer and automatic load on my application. In terms of the logs, each node has FusionReactor installed, sending metrics, traces, and logs to the cloud. This includes scraping my command box and Cold Fusion logs. Nginx has a Promtail agent sending process logs to the cloud using an API key as authentication. For the demo itself, we're going to show you how FusionReactor can do your log content both live and historically from multiple sources, filter log content for diagnostic purposes, visualize log data as metric-based graphs, dashboards to visualize log data and spot issues at a glance, create alerts for potential issues for quicker issue resolution, and diagnose issues faster making use of the extra context in logs. This will help us find a server attack, background or hidden errors, extra context on application performance, and diagnosing server crashes. So the first situation we want to address is a server attack. This is someone trying to brute force their way into your application, and it can be a very unpleasant situation. Now there is of course a risk that the attacker can actually breach your system, but even if this doesn't happen, the side effects can be severe, sometimes going as far as bringing down the application entirely. Now as you can see by this top graph, we recently ran a simulated attack on our server, and we have a high spike in throughput to our application. We had a similar attack at 10:40 an hour earlier. Now I could use the metrics and the transactions in combination to find my problem, but there is a superior way of doing this, and that is using logging. Now this is superior for two reasons. The first is that we can see summary information, so we can right now see all requests across all three of our nodes. The second is that we have access to extra context from our Nginx, so we have our Nginx access logs on top of our request logs. Now we could diagnose the issue using the log lines. We can see if we get into a request, we have an IP address per request. So we know where our attack is coming from, and we have a URL, so we know what the attackers are doing. But the problem we can see is that each request has the same IP, and this is because this is actually the IP of Nginx. So instead we need to run a slightly different query. Now for this query, I'm actually going to use the Nginx access log, because this will contain the true IP address. But as you will see, I am not running the log line query itself. What I'm doing is taking the IP address from my log and converting it to a graph. So I'm generating a metric based on the graph as opposed to looking at the log lines themselves. And you can do this because we use logql and we have a very powerful log query language. Now when we do this, we can see that 10:40 at the start of our attack, we had a massive spike in traffic, and it was all from a single IP address. Then we have our standard simulated load, and the next attack, we can see there another spike in traffic from the same IP address. We can see right now that the attack is actually coming from one single machine. So this is not a distributed attack, this isn't DDoS, this is one single machine trying to brute force their way into our application. Running another metrics query, we can actually see what the user was doing. So now I'm going to process my request log again, and I'm going to process it this time, but I'm going to run a metric query to look at page hits. Now when I do this, I can see during the attack, I have a large spike in traffic to my login page, but every other page is reasonably unaffected. So we now know what the attacker is doing. We can isolate the fact that there is one single attacker, and they are targeting the login page, most likely to try and gain access to the system. So we know the cause of the attack, but what we don't know is, what did the attack do? Did they breach our system? Did they cause any performance? And we can do that in logs by highlighting the period we want to inspect. And that will bring us the raw log lines for the time. What we can do is we can click on the log line, and this will show us the fields and labels attached to this log. Now for any numerical field, such as execution time for example, we can click on the graph icon. This will generate us a graph of the, in this case, execution time. Now we can see here the attack started at 11:40, but there was no major rise in execution time across our stores. We could do the same for CPU time, and we can do this for any metric. So for example, free memory or max memory. And you can see that during the time of the attack, there doesn't seem to be any noticeable side effect. Everything seems to be relatively consistent. We can also view statistics on certain fields, so for example our status code. We can see that even with the attack going on, we only ever saw a status 200 code be returned. So we didn't have any errors because of this particular attack. You can do this, for example, with thread. So we can say, during this attack, we saw a large number of threads execute, but we don't have insane numbers of threads, and everything seems to be healthy. So you can use logs to tell that when you have an attack, what caused the attack, and were there any side effects. For a long time, debugging with logs and using logs to capture extra context for a problem has been a very standard process. The problem with an approach like this is that you have to actively monitor logs for this information. Otherwise, while your application may appear to be working for every user you have, there may be errors that you are completely unaware of. It's also easy to forget to monitor these logs, or forget even that these logs exist. A developer could add a try-catch block that logs and ignores errors, then maybe forget, or your developer moves on and a new developer begins. At this point, you can forget this log context exists, or you're completely missing out on some problems. You can actually just use broad text search on your logs. So for example, I could do a broad text search on error, and I can actually see in my application, even though there are very few errors that appear to be running, there are actually quite a few errors, and you see they're running quite frequently. So we've probably got several times a minute we're actually seeing this error that a division by 0 is not possible. Now this is a debug log that someone's added to an application in a try-catch block. But you see here that we don't have a stack trace or anything pointing to the location of the error. So this debug log in itself tells us there's a problem, but it's difficult to find out the exact root cause. Into our application, we will see that we do have some errors. And they all seem to be in a page that we have called Buy Now. But you'll see that the error is not the same. This is a payment declined exception. This is not anything to do with this division by 0. Somewhere in our code we have this block, and we're having these errors. Now with logs you can find the error. If we have a stack trace, then we would obviously know the page that was being hit. When we don't, what we can do is we can investigate the code and find where the log is occurring. And there are several things we could really do to actually address the problem. So the first is you could enhance your debug logs. Instead of saying error division by 0 not possible, you could say the page this was firing on. You could add a stack trace, something like this. Your other option would be you could completely remove the log, and you could let the code error normally. Now when that's the case, something like FusionReactor would be able to actually find the error, and it would give you context for the error automatically. Or alternatively, you could connect a debugger to your code to really find the cause of the crash. But logs enable you to really search all this data. So I can search across all my log files for exception or error, or if you have a custom message you know explicitly is logged, you can search for that value to find something hidden in your logs that you may not be truly aware of. Earlier, at the start of the demo, I mentioned that we have 3 nodes of our store running and processing requests, whereas now you see we only have 2 nodes. Now there are many ways in which a server can crash. You can have crashes where the server death is less obvious. So your JVM may be operational but not processing requests, or parts of an application can break due to resource limits, or you have an application that crashes but auto redeploys so you don't notice the downtime. But in my experience, the most common crash is where the JVM process will simply halt, and this is the case I have now. So we can see that my stores 1 and 2 have been up for 5 hours, but an hour ago my store 3 instance crashed. Nothing here to cause or indicate a problem. Throughput was normal, metrics were normal, everything seems stable. If we look at our transactions, we look at errors for the time of the crash, again nothing seems to be out of the ordinary. So we have our standard errors that we know are occurring, but everything else seems to be somewhat uniform. Nothing here sticks out as an obvious problem. What we can do, however, is look at the logs, because this server is sending its command box and CF logs into FusionReactor. So providing the death of the server was logged, we will see the cause there. Into my application logs, my error logs, and my command box logs. And this will show me the final lines before the death of the server. So we can see here my normal errors, but at the bottom we see info level logs about record processing, which is info level debug logs I have specifically on my reports page. But above that we see the actual crash. So we see there was a Java outer memory error in the Java heap space, which caused the process 1 to exit. And this is the death of my JVM. So we can see here the actual death of the server and what caused it. What we can also do is we can search this in the text search. So let's say for the past 12 hours, we can see this happened at 13:44, this happened at 12:57, 11:26, and 10:04. So this actually seems to be a recurring thing where my instance will crash. This isn't a one-off event. This is something we know is happening regularly. The cause of the crash may be difficult. So why we're running out of memory is not something we can necessarily derive from the crash. But we think it happens when the report page runs. So what we could do is, instead of searching just in these logs, we can add our request log. And then in this case, we're looking for report.cfm. We can see this is occurring at 10:04, 11:26, 12:57, and 13:44. So we can correlate when the reports.cfm page runs and when the server will crash. So we know the page that's causing it, but obviously there's more work to do. You would need more analysis on the code. You would need to look at its memory usage, its object use, things like this. So you would need to do a proper deep dive of the code, maybe add some more debug logs to catch the actual error that's occurring and causing the out of memory. And this is a critical issue. So we can look at the cause, but in the meantime, what we also want to do is we want to know it's happening so we can act on it, because it's occurring fairly regularly. And to do that, I'm going to set an alert. What I'm going to do is add an alert to my application group. Now this group I have will check once a minute for rules, so as soon as there is a crash, I will be notified of the crash, and I can look into either recovering the server, or checking my debug logs, or whatever I've done to address the situation. So the first thing I have to do is create a new rule. Now an alert is slightly different to the log events explorer in the fact that I have to have a numerical value associated with it. So I'm going to use the same query I used before to look for an out of memory, but I'm just going to count the number of times it's occurred in my logs. Now immediately you see an event at 10:05, an event at 11:27, an event at 1:02, and an event at 1:44. So we know when the alert fires, and the next time it fires, this alert will trigger. I need to give my alert a name, so memory crash. I need to give it a place to go. So this is all your pre-existing subscriptions, and in my case I'm going to use a Slack webhook, but you could use email, pushover, OpsGenie, whatever else you want, and you can select multiple of them. You have a pending period, which isn't so important for this alert, and I will cover later. The summary of the issue, so node crashed with out of memory, check everything recovered, and then you have a runbook. So if you have a place you store runbooks of how to action alerts, you can add the link there, and it will be added to your alert. Then when this does occur, I will get the message in Slack. While logs can be used for debugging or diagnosing problems, they can also just be used for providing context. You could have info level logging in your code that says what a user may be doing, or just helps you ensure that everything is running smoothly. You can have extra metrics in your logs, anything like this. You can also use metrics within your logs to provide context views you can't get anywhere else. For example, we can run a query on all pages that will show me the pages I'm running that use the most CPU. Run a query looking at bytes returned as part of your application, so your response time to the end user. You could look for which logs you are actually being generated as part of your application. So with logs, you can do a lot more than just use them for debugging. They actually contain a lot of data that you can harness. Now the problem with this is what I'm doing right now is I'm running each query individually, and I'm only doing this when I need it. But you can't really do this by analyzing this data on a regular basis if you have to do it all manually. So this is why you need an automated manner of doing so. And this is where dashboards come in. So this is what we do ourselves. We have a series of dashboards that run our entire cloud deployment. And from this, we can see if everything's healthy, if everything's running smoothly, if we have any problems. So we can easily monitor these dashboards, we can pick up problems, and we can fix them before we get reports from customers that we have a problem. So this helps with stability, it helps with performance, and it helps generally to have vastly reduced downtime. Now right now, you can see I currently have 4 dashboards. I have a dashboard called log rates, I have a dashboard for my balancer, I have a dashboard for store details, and I have a new dashboard that I've just created. Log rates dashboard. This is going to show me my log ingestion. I can see where my logs are ingesting from in the various different jobs I have. So my 3 stores and my balancer. I can see log rate over time, so when I have spikes versus my normal logging rate. And I can see errors per job. So I can see I suddenly have an increase in log ingestion over time, for example. So something happened at around 1:45 that then caused my errors to increase, and at 1:50 this stopped. I have a balancer dashboard, and this is examining the performance of my load balancer. So I have traffic by IP for if my server is under attack for any reason, or I have increased load at peak times during the day. I have a status code breakdown. So I can see I've constantly got some 500s, but not many, but most of it's 200s. If I have a problem, suddenly I may see something unexpected, and the results may differ. And I have a response bytes graph, so I can see from the traffic IP addresses hitting my server, are the responses suddenly increased in size? Now what I can do with any of these graphs, like I did earlier, is I can highlight an area of the graph, and that will give me the lines. There I have my log itself, all of its fields, so I can use the statistics and the graphs. I also have the context to show the log surrounding it, so I can deep dive straight from a graph into root cause detection for a problem. You can use dashboards to visualize your logs and spot patterns in your logs. This stops the need of hunting in your logs to find problems, as you can see them at a higher level. But without an alerting component, you will still need to actively monitor your dashboard to see a problem. With alerting, we can tell you that there is a problem, and then you can act on the solution. Now the first is an event-based alert. And we already covered this with the server crash we had earlier. This will tell me when I have a Java out-of-memory error, and let me know that I need to act. I need to make sure my system has recovered, and that everything is stable. The second is a rate-based alert. Now rate is a function of logql. And instead of using the value of a function or field, it will use the rate of change for that field. So a good example of this is a log flood alarm. So this will basically trigger if ever I have more than 15 logs per second for a job sending me logs. So if my balancer suddenly increased to over 15 logs a second, I want to know something out of the ordinary is happening. I'm under heavy traffic. If one of my stores logged more, that could mean I had a flush of errors, or something isn't behaving as it should. One thing to note with this one is that I'm enforcing that the issue must occur for at least 5 minutes. So I want to know that I'm having a prolonged log flood, otherwise this could trigger for an accidental restart. The third type of alert is a value-based alert, and this is using the actual value of a numerical function or a field within your logs. Now you could calculate this using a logql function such as sum over time and counting the number of rows, or you could unwrap a specific value from a log and use this to alert. My first example, I'm using a sum function and I'm counting the number of error logs that I'm ingesting, and I'm dividing that by the total number of logs I'm ingesting, and I can use that to calculate a percentage. So this alert here is comparing two values, which allows me to calculate whether I am ingesting more than 5% of error logs from my application. Ordinarily, I'm running at around 1% of logs being ingested are errors. If I suddenly see that increase to 5, something bad is going on. What I'm doing in this second example is I'm unwrapping a value from the logs. So I'm unwrapping the CPU time from the log. I'm taking my request log, and I'm getting the CPU time, and I'm getting the total execution time. And again, I'm dividing the two to make a percentage. What this allows me to do is generate a query that will tell me if at any point one of my pages in my application is using more than 40% CPU. So if my execution of a single page is using more than 40% of my total CPU time, this to me is unacceptable because this will cause performance issues within my server stack. Now right here, I'm using two values for my request log, CPU time and execution time. You could use this for, say, database time versus execution time. Or you could compare completely separate log files. So memory and garbage collection, or my DB pool stats versus total database execution time. Any value you have within your logs, you can convert to be metric-based alerts to tell you there is a problem. So alerting is the final piece in the logging puzzle, because it will tell you something is wrong and give you time to act before it's too late, before you get your customer complaints, before the system goes down. It gives you that warning that something is happening without having to sit there and watch the issue occur yourself.
Hi. Okay, so before we go to the summary, thanks, Mikey. First of all, that was very informative, and I hope everybody was able to see it okay. I think that the quality wasn't amazing. I had to increase the quality for the rendering, but once I did that, it was a lot better. Okay, so finally, a few final tips and tricks for logging. So what we mentioned earlier, use fields or labels to maintain data granularity. So I think what Michael showed us earlier is what you can actually get out of your logs if you're using labels, if you're running FusionReactor and you're using our logging or this logging capability to ingest the logs. We do automatically detect all those labels, so that's all going to work. But if you're writing your own logs, then you should definitely define some fields or labels. Define standards for everybody to use. So I mentioned this earlier as well, not that all the different developers are all using different standards when they're writing their logs. That's not very good. So you should definitely define something before you start writing your logs. Only log what really adds value. Probably an obvious one. If you write too much stuff, then you're just going to get flooded, and then you won't find you won't be able to see the wood for the trees. And also retrofit logs that can help. So if something does go wrong and you've got a situation where an error occurs and you didn't have the right logs in place, we do recommend that you go back proactively, change your code and include the logs, and hopefully you'll be able to find that issue next time. So a quick summary, we took a look at who uses logs and why they're important. We did an outline of a do-it-yourself log system based on Grafana Loki. And then Mikey showed us how FusionReactor is adding logging capabilities to add even more value. If anybody's interested, if there's anybody in the audience that is interested in trying out this logging capability with FusionReactor, we've actually got a beta program running at the moment. If you just go to fusion-reactor.com beta, then you can sign up for that. Or if you drop an email to sales@fusion-reactor.com, we can also get you signed up. And if you'd like a trial or a demo of FusionReactor, again, just go to fusion-reactor.com. So that's it. Thank you for your attention, everybody. And please let us know if you've got any questions. Okay, any questions? Where are you guys based out of was a question. We're actually in Germany. So that's why I've got the lights on, it's pitch black outside. So we're in Germany. We do sales out of the US, and we've got an office in the UK as well. but Mikey and myself are in Germany. Any other questions? I think probably these presentations are all being recorded. So if you wanted to take a look, or you have a look and think of a question afterwards, I think it's fine to just come back to us. Again, you could just drop an email into sales@fusion-reactor.com, and we'd be happy to help. So another question, did you guys build FusionReactor with Cold Fusion? Just curious. No, we didn't build it with Cold Fusion. We did a lot of Cold Fusion. Okay, what resources does FusionReactor use in a production environment? Processor, RAM, etc. FusionReactor uses around about 1% of your resources which are on the machine. So we put a lot of work into FusionReactor so that the impact of what you're actually monitoring is as low as possible. And that was always one of the design criteria right from the outset. So it's around about 1%. If you compare that to other monitoring solutions, very often other monitors are landing somewhere between about 4 to 8% of performance hit. Last 2 minutes for the session to end. Okay, any other questions? The other question which came up was, did we build it with Cold Fusion? The answer was no. It's pretty much built in Java. And like I said, we did do a lot of Cold Fusion development. Back in the day, we started working with Cold Fusion in 1998, I think just before CF3 was launched, and we built some very, very large enterprise scale applications. Yeah, so we've been working inside the CF community for a long, long time. Does FusionReactor support all Cold Fusion versions? With the current version that we've got now, that goes back to CF8, I think, or CF9. Mikey, correct me if I'm wrong. If you needed
CF8.
CF8, yeah. So if you needed to support an earlier version of that, we could also do that, but you'd need a FusionReactor version 5, I think, if you wanted to go back that far. We're currently on FusionReactor 8 is the main version that we've got. So, of course, if you wanted to license an older version, that would also be possible. But generally, we're keeping up with Adobe. So whenever Adobe make a new release, we coordinate that together with Adobe so that you can instantly start using FusionReactor with the latest version of CF. Okay, 30 seconds left. Any last questions coming in? Okay. Oh, so last version of FR support for CF 2016, the latest version of FusionReactor supports CF 2016. I think Mikey, the last version of FusionReactor for 2016, would that have been? I mean, the current version supports 2016. That's the answer.
Latest supports it. It was probably early 7 that we added support for it, somewhere around there, maybe.
Yeah, could be. Okay, session as ended. Okay.